Warm chicken salad, apparently. All right.
No. Buffalo wedges, though.
What are buffalo wedges?
I don't know, but it sounds
Potato wedges.
Oh, there's potato wedges.
Oh, that's just good. Potato wedges are delicious. All right, guys. If you guys want to get up early for that lunch,
Yes.
Yeah.
we got to do it. Shh. We got a lot of work to do. Okay. All right. You're in the way of the camera. Okay.
2 days in a row, being
All right. So a quick, quickly, what I want to do is make sure we got a good hand on how matrix multiplication works. And we're also going to look at how to use a calculator to do matrix multiplication.
Yeah, I wanted to ask that question, I just had no idea.
Okay, so let's do a quick example here. And this is the very first one I assigned for homework last night, number 25 here. Okay. This is a good example. This is a good example of what I meant before about commutativity and things like that with these problems. Matrix A, okay, is 2, 1, negative 3, 4, negative 1, 6. So 2, I forgot already. 2, 1, negative 3, 4, negative 1, 6. And B is 0, negative 3, 0. Okay, 4, 0, what, 2? Yes. 8, negative 2, 7. Okay. What's A times B going to be here? Somebody want to tell me?
Impossible.
It's impossible. Good. Okay. A times B is impossible. Can't be done. Okay. The reason is this one's only got 2 columns, while this one has 3 rows. The rows of the columns of the first one, the rows of the second one don't match. Therefore, I can't do matrix multiplication to this. However, if I were to flip these around and do B times A instead, okay, I can actually do that. So B times A, and I'll just rewrite the matrices to make our life a little bit easier here.
So were we supposed to do a thing, B times A?
No, I'm just kind of carrying this to the next, because this is a great problem to show all these principles, okay? If I were to flip them around, can I do them now? Yes. I have 3 columns and 3 rows. That means these can be multiplied together, okay? And so just as good practice, let's go ahead and actually multiply these things together by hand, okay? Can I?
Give that here.
Yeep. There you go.
Wait, can you upload the video from yesterday?
It's already up there. It's on YouTube.
It's the 20. The last one you did is the 27th.
Right. It takes a while for these films to show up.
Okay.
It could take a few hours. I uploaded it about 8 o'clock last night,
Okay.
so it should be up there now. And when I checked my account, it said it was in the process of being set up. So if you check it now, the video should be up there. I know somebody in a different class said they saw it. So, all right. Doing this multiplication real fast here, okay? Basically, just doing it by hand. Remember, we're going to multiply the row by the column, okay? And just kind of do the result. So it would be 0 times 2 plus negative 3 times negative 3, which is 9. 0 times negative 1. First number,
9.
done, okay? Then, same thing, just use the second column for our second number. 0 times 1 is 0. Okay, negative 3 times 4 is negative 12. And then 0 times 6 is 0. Okay? Now, we're done with columns, so we move on to our next row and repeat the process. 4 times 2 is 8. 0 times negative 3 is 0. 2 times negative 1 is negative 2. Okay? Then we repeat. 4 times 1 is 4. 0 times 4 is 0. 2 times 6 is 12. Out of columns, next row. 8 times 2 is 16. Negative 2 times negative 3 is plus 6. 7 times negative 1 is minus 7. Okay? And the final things out. 8 times 1 is 8. Negative 2 times 4 is negative 8. 7 times 6 is plus 42. Okay? So my final answer then would be 9 minus 12, 6, 16, 15, 42. That's my answer. Okay, doing it by hand. Any questions? Okay.
So rows need to match.
The number of columns in my first matrix has to match the number of rows in my second in order to do the multiplication. Okay? If they don't, you cannot do it. No dice. When you try to do it, you would quickly see why it didn't work. Things wouldn't line up correctly. Okay? But the actual process of the multiplication is do the row by the column. Okay? Adding the results together. That gives you the first number in the first position, and so on and so forth. Okay? Alright. Good. Now, let's do the same problem, but let's use the calculator to give us our answer. Okay? So, bring up our calculator.
Calculatrice.
Hate what those is. Okay. Get rid of that. Alright. Now, the thing about the calculator, in order to do these multiplications, you kind of have to program the matrices into it. Okay? It treats its matrix operation as the same way as it treats its programs. Okay? Now, it's not too terrible to do, but just realize there's lots of different little steps involved, and so you want to just make sure you're clear with things, okay, as you practice with it, okay? But what you want to do is you want to go into the matrix menu, and if you go to the first row of buttons on the far left of the calculator, fourth button down, it says x to negative 1. If I hit second that button, it brings up the matrix menu. You know it because it says matrix in the top in little blue script, okay? So bring that up, and it shows names, math, and edit.
Wait, which one is it? Which one is it again?
X to negative 1, so you hit second x to negative 1, that brings up matrix.
Okay.
Okay? So you should say names, math, and edit. Okay? Names, that's actually where you choose the matrix you're going to use. Math is the calculator's functions that are just for matrices. So if I wanted to do a matrix-specific operation, that's where I would access it. And edit allows me to program the matrices in. Okay? So what I'm going to do is I'm going to scroll over to edit. Whoa! That is an impressive gust of wind. Ah.
The tiles.
Yeah.
We should probably evacuate the building before something bad happens.
Nah, we're fine. Yeah. All right. Let's program it in. The very first question it will ask you, everybody, is it wants to know what the dimensions of the matrix are. So matrix, our first matrix here, I'm kind of matrix A. If you remember on the problem, was a 3 by 2 matrix. So I'm going to enter 3 and then 2. Okay. Now it's going to ask me to fill in the numbers, and I just fill in the numbers.
How do you do that? 3x2?
Yeah, you hit 3, enter, 2, enter. Okay? And a lot of this is entering your number and then hitting the enter button, okay, as you fill it in. So it'll ask you order first. Matrix A, here our problem was 3 by 2. Okay? Then we just fill it in. So
When I hit enter, it says undefined.
No, go to edit and then click enter and then go back and then you enter all the stuff.
yeah. Yeah, it is a little odd getting used to it at first. Alright, so plugging these numbers in. First number was 2, so I hit 2.
Got it.
Enter. 1. Enter. Negative 3. Enter. 4. Enter. Negative 1. Enter. And 6. Enter. And that has filled in my matrix in the calculator with these numbers right here. Okay, everyone see that? Alright. Now, I do the same thing, but with matrix B, so I just go back into my matrix menu. You have to hit second matrix again. Zoom over to edit. Go down to B now. Hit enter. And it'll ask you first, what's B's dimensions? Our matrix B is 3 by 3.
Alright, so once you finish all that, what do you do?
Focus.
Alright. Yeah, you go back into the matrix menu and pull up the next, and do it for the next matrix, okay? Alright. You there? B, and it's a 3 by 3. Okay. Might have to close that window.
I think we should leave it open.
Nah.
All right. Now let's fill. Again, we're just going to fill it out here. Same way we did before. We just enter the numbers. Every time you hit a number, you hit enter, and that will fix it. So it'll be 0, enter, -3, enter, 0, enter, 4, enter, 0, enter, 2, enter, okay, 8, enter, -2, enter, 7, enter. And there I have it. My matrix has been programmed in, okay? Now, what I want to do next, everybody, to actually do the operation, what I've got to do is I've got to clear out everything. So I'll hit second quit. That gets me back to the regular calculator screen. And now I go back into the matrix menu, and I select the matrices I want to multiply. So I'm going to do B times A. So I'll check B first, then write times, pick A second. There's B times A, hit enter, and it spits out the same exact answer we got when we did it by hand.
Awesome.
Okay? Awesome sauce.
Alright, so you go to 2, you go to B, you hit what?
Enter. And that selects it. And so on the regular screen it should say B, then you just hit times, do the same thing to pick A, we get our answer. Okay? Because you guys know, honestly, close the window a little bit more in the back. We can keep it open, just not have it be open so much, and that should prevent the wind from blowing the tiles.
And then you just enter again and you get it. Alright,
Got it to work? Alright. That's how you use the calculator to multiply matrices.
why do we do that every time?
Well, because as you notice, this can take a while to do by program the calculator to do it.
It's faster than by hand.
Well, for you, if you think it's faster than my hand, then yeah, you could do it, use the calculator every time. I think for small matrices, like these two matrices here, I could do that by hand much faster than I can entering all the numbers in here. Okay. Really, the calculator is best used for the matrices get big.
Number like 61, where it's like A.
So 61 here, yeah. So if we did matrix 61 in this, okay, 61 is involving like lots of different matrices together. We can do that arithmetic using the calculator fairly quickly, okay? And it would be better to use a calculator for that, okay? But for these small fry, just doing it by hand is much easier, okay? But does everyone understand now how to program the calculator? Okay? And again, if you need to, just watch the video tonight, and it'll help you out, okay? But that's how that works, all right? Any questions there? All right, we're going to move on then for multiplication, okay? Multiplication, you should have a good handle of how it works now, all right? I will say this, there's nothing difficult with multiplication. The big thing, though, is just to make sure you practice it, okay? To make sure you got that kind of system down. All right, what we're going to look at next, okay, that one there, okay, is we're going to move on. We're going to talk about our next subject with matrices. This is going to be called the determinant, okay? All right, what a determinant is, okay, for matrices, because you've seen the word before in with quadratic equations. But for matrices, a determinant is basically a real number that is a, I don't know the best way to call it, byproduct maybe? Of a matrix. Okay, I can think of it as taking the matrix and expressing it as a single number. Oops. Okay, so basically, what a determinant is basically like I've got this big old matrix, and it's essentially like I'm boiling it down or condensing it down until it becomes a single number, okay, which I can then use to do work with, okay. By themselves, determinants don't really have much meaning. what they're really used for is in the applications. I can, once you take the determinant of a matrix, you can use that determinant to find things like an inverse matrix. You can use it to find things like, if I'm solving multivariable equations, one method is to use just determinants of matrices, and that gives you the answers very quickly. So they do have a lot of use, okay? But that's, so basically, that's what a determinant is. Now, to find a determinant, okay,
What did that say under IE?
Expressing a matrix
as a single number, okay? Okay. First, you can only find determinants for square matrices. And there's two different ways. One for 2 by 2 matrices, and one for 3 by 3 or greater matrices. This will be a common theme, by the way. You'll notice we'll have we'll have these special ways of doing things for just 2 by 2 matrices, and then every other matrix, 3 by 3, 4 by 4, 5 by 5, will have the same kind of method involved in solving it. Okay, it's just something to keep note of. All right, so let's look at the 2 by 2 one first, because that's actually pretty easy. Okay. Okay. The determinant, and you take a determinant with you use the word det, that stands for determinant, okay, of my matrix A, B, C, D.
Isn't that like a chemical?
DET, yeah, it's that awful stuff that, it's that awful pesticide they used that killed a bunch of birds.
DDT.
What is that, D?
DDT.
DDT?
No, it's like debt. DET.
Oh well, whatever.
Spelled like you have a debt to a bank.
Okay. How this works, everybody, okay, is you, basically, to find the determinant involves multiplying diagonals together. So what I'm going to do here is I'm going to multiply A times D, that diagonal, okay, and subtract from it the other diagonal, C times B, okay? And that result is going to be my determinant, okay?
So you can do, with this community probably, can you do CB or BC?
If you did the other way around, so do BC minus AD first, and you get the negative number determinant, okay? Because it flips everything around, okay? So this is the way you find a determinant, just like this, okay? So an example with real numbers.
Do you subtract them?
Yeah, you're going to subtract the results. So let's do an example with actual numbers here, okay? We'll keep it simple. 2, 5, 1, 9, okay? That's going to be 2 times 9, which is 18, minus 1 times 5, which is 5, which gives me, what is that, 13. So the determinant of this matrix is 13, okay? Okay, just like that. Okay, 2 times 9 minus 5 times 1 or 1 times 5. That's how I get 13 as my answer, okay? Pretty easy, right?
But what's that number? Is that a 1?
Yeah. Okay, pretty easy. The determinant of a 2 by 2 square matrix, super easy. Okay, just like that. Okay, now for 3 by 3 and greater, the process gets a little bit more involved. Let's take a look at one of those next. Okay, and you can use the calculator, by the way, to figure it out. But let's do it by hand first. Okay, so we're going to figure out the determinant of a 3 by 3 or greater One thing we're going to do here, and I just want to be clear what the actual step is whatever matrix we end up finding the determinant for, we're going to augment. Okay. Now remember, matrix augmentation, all that means is that I'm going to write extra information that's not part of the matrix, but that will help me to solve it. Okay. So our 3x3 matrix, let's make matrix A equal to A, B, C, D, E, F, G, H, I. Okay. So how I would find the determinant of A is I'm going to take the same matrix I had, and I'm going to augment it. What I'm going to augment it with is I'm going to basically repeat the very first 2 columns. If this was a 4x4, I'd repeat the very first 3 columns. If this was 5x5, I'd repeat the first 4, etc. In the augment. And you're going to see why here in a second why I do it. It's only to help line things up neatly, to make my life easier with the next step. Okay? Okay. So there's my augmented matrix. And how this works here is, again, I'm going to do the same thing with the diagonals. It's just because my matrix is bigger, I'm going to have more diagonals I have to calculate. Okay? So my first diagonal is A times E times I. Okay? And I'm going to add to that the diagonal BFG. Okay? So hence why that augment is there now, so I have that nice lineup,
So
basically.
you don't
do the last line?
to the augmented part?
Nope, you leave out that one. You don't need it for this next
Why?
part. You'll see here in a second. Okay?
So you always just add the first 2?
Yeah, first 2 or first 3 or first 4, depending on the order of the matrix. Okay? So the next one we get is BFG. Okay? Then same thing, CDH. Okay? Okay? So that's why I didn't have to go any more than just the first 2, because the 2 extra lines there are what just help me set up these diagonals. Okay? Do you see that? Once I hit C, I'm at the end of the matrix, so I don't have to go any further. Okay? Because remember, the 2 extra lines are actually not part of the matrix. They're just there to help me with this process. Okay? Any questions there? All right. So that's the first diagonal's done. I'm going to do the same thing, but in the second direction, but in the opposite direction now. So I'm going to subtract from this G times E times C. Plus HFA.
This is crazy. So you don't worry about the D.
Huh?
That D right there.
Right there? Nope. Well, you touch it, but you get it over here. IDB. Okay?
Oh, I got it.
All right. There's another way of doing this, by the way. I know some people who don't write the augment. They just realize you wrap around. So it goes AEI, BF, then wrap around the G, C, wrap around the DH in the one direction, and then do the same thing in the other direction. GEC, HF, wrap around the A, I, wrap around the DB. Okay? And that gives you the same results. But the augment makes it a little bit nicer and a little bit easier on the eyes to see how it works. But that's all you do. And so whatever the answer to all of this right here is going to be my determinant. Again, it's just going to be a single number, like 12, or 84, or -4. Okay. All right. That's it. Let's take a look with actual numbers here. Okay. Yeah, I'll keep it up for a second. We'll take a look with actual numbers.
What's wrong?
Just saying,
Why?
it's been a long day.
I think we need some more lunch.
Yeah? In like 10 minutes.
We
Actually.
had 5 straight classes and a live period.
Yep. Which is why this is a long day.
I don't have one for your today.
Are you gonna do the baseball game today?
Yep.
Who are you?
You know the baseball players has to get to the game.
At 1:15.
It's absurd.
which is kind of crazy since you have a 4 o'clock start.
Honestly, it's crazy that we have to do that for baseball.
Got this down? All right. Okay. Almost done.
No, I got it.
Okay.
Quiet down.
All right.
Come on, buddy.
Good. All right. So example with actual numbers, and then we'll use the calculator. The calculator makes life easier on us. Okay. So we'll do a 3 by 3 with actual numbers. So I don't know, 3, 0, 8, 5, 4, 0, 7, 1, 6. Okay.
5, 4, 0.
Yep.
8, 0, 4.
Okay. There's our matrix. We'll call this A. We want to do the determinant of it. Okay. How I'm going to set that up then is I'm going to go ahead and augment it. 3, 0, 5, 4, 7, 1. Okay? And then work out the process. Okay? So it'll be 3 times 4 times 6. Okay? Plus 0 times 0 times 7. Plus 8 times 5 times 1.
007.
Okay? Subtract that. 7 times 4 times 8. Okay? Plus 1 times 0 times 3. Okay? Plus 6 times 5 times 0. Okay? So, that's going to be my determinant. Now it's just a matter of working out what all these numbers are. Okay? 3, 4, 6, let's see, 24 times 3, that should be what? 72. No. Yeah, 72. Okay? Plus 0, plus 40. Okay? Minus 28 times 8 is 160 plus 64. So 224, thank you.
7.
Okay.
7 times 4 times 8.
7 times 4 times 8 should be 224. So it's 24 times 8, which is 160 plus 64, which is 224. Okay? Plus 0, plus 0, because those go to 0. So working this all out here now, we get, let's see, this is 112 minus 224, which is equal to negative 112. So negative 112 should be the my determinant.
That's 40.
Huh?
Never mind.
That's a 40, yeah. 40. Okay? All right. Again, we can use the calculator to figure this out. Okay? A 3 by 3 matrix, you should be able to do determinant by hand, again, fairly quickly. It's for the bigger ones, 4 by 4, 5 by 5, 6 by 6, etc.
What about like 20 by 20 the way I do those?
Probably not for me, because that would just be stupid.
How long would that take?
You would use a calculator on a 20 by 20. I would never ask you to do a 20 by 20 determinant by hand.
That'd be crazy.
Okay, Scout's honor. Okay.
19 is the highest you'll go.
19 by 19, yeah. Okay. All right. Quickly now. We'll go ahead and program this matrix in.
How do you clear your calculator?
That's one thing. It's a little hard to clear these out. I just don't. I just let them be because they don't really. Since you have to reprogram every time anyway, there's no reason it needs to be a fresh one. Okay. So
Don't get rid of your.
the matrices. When I put them in, I usually just let it be.
Oh, you just edit the numbers.
Yeah. Okay. So it's 3 by 3. Since you have to enter them all in anyway, so 3, 0, 8, 5, 4, 0, 7, 1, 6. Okay? So that's the matrix with my numbers filled in. Go ahead and quit out of that. Go back to the matrix menu. Select math, and the very first one, DET, is determinant. Select that, and it'll ask you determinant of what? Now I put in my matrix A. From the matrix menu. Okay? Hit enter, and it pops out the answer, negative 112. Okay? Doing the math for you. So notice the calculator can do a determinant much faster than I can by hand. Okay? Everyone catch that? That didn't take very long to do at all. Okay? Alright. Any questions about these determinants?
Wait, are we gonna have a test this week?
Yes.
Can we use a calculator?
On the test? Yeah.
How do you enter the
Not for
A
all of
into
it,
the
just some-
determinant?
Huh?
How'd you enter the A into the determinant?
Oh, same way I did before when I did A times B. I hit second matrix. Whoops, no, second matrix. And you just click on A. That brings up matrix A.
Okay.
So if I want to do A times the determinant of A, this would be kind of a neat little thing to do. Whoa. Oh, that's A times A right there, so that's A squared. That's not what I wanted. This is just me being silly at this point. Okay. But it should give me an answer just fine, because remember, a determinant is a single number, so it's going to treat that as a scalar, multiplying by a regular matrix, and out pops all my numbers. See?
Pretty cool.
Pretty crazy, isn't it? Okay. And you can just go through
Alright, cool.
and work all matrices that way. Okay. Now,
Alright, cool.
it's chopped off some of the numbers out here, but you should be able to scroll and see
Is that
them
all
if you hit
that
over.
was?
Okay. So yes, this is all we're going to do today. We'll save talking about the introduction to inverse matrices for tomorrow. Okay. Which use determinants to calculate. The other thing, everybody, again, there's a test on Thursday. It's either Thursday or Friday. It depends on when we have our last class. Is it Friday? Okay. I'll have to look at the calendar because I know there's special schedules. Okay. There's special classes, so we'll make it to whatever the last class is. All right. Y'all have a good day.